class, today we are going to be doing a problem over time. So let's look at our problem that we have today. Roseanne has a busy day of running errands around Lubbock. It is 2:30 p.m. and she's leaving her house for Sprouts. She has to be home by 6:15 p.m. to prepare dinner. How many minutes does she have until she has to be back home? So first we're going to use the set model of our time tracker, and we are going to solve this problem. So let's look at our important information from the problem. So it says Roseanne has a busy day. It is 2:30 p.m. So that will be our start time. Now it says that she has to be home by 6:15 to prepare her dinner. So that will be our end time. And then we're trying to figure out how many minutes does she have until she has to be back home. So how many minutes? So let's look at our hours and our minutes and our start time. So we are going to put on our hours 2, and then on our minutes 30, because that is our start time. Okay, we are then going to make 60 and add 30 minutes. In order for us to be at 3 o'clock. So since we made 360 because we had 2:30 and 30 more minutes makes 60, which gives us a full hour, it is now 3 o'clock. That is just like regrouping in base 10, but we are going to 60, so that's the difference here. Alright, so next we're going to make another 60 and jump by the hour. So we will go to 4 o'clock, and that'll be 60 minutes. Then we will make another 60 and we will jump to 5 o'clock. Then we will jump one last, make 60 to get to our 6 o'clock. Alright, now if we go back to our problem, it says that our end time is 6:15. So if we're at 6 o'clock right now, that means we need to add or jump for 15 more minutes. So we're going to jump 15 minutes. Alright, so now we have 6:15 and it matches our end, so we can stop. Over here is all of our minutes that Roseanne had while running errands. All the minutes that passed while Roseanne was running errands. So if we want to know how many minutes does she have until she has to be back home, we need to add up all of the minutes. So we have 5, 6, 12, 18, 19, 20, 21, 22 minutes. So it took her from 2:30 to 6:15. She had 225 minutes for her to run errands and get back home to prepare dinner. So this is using the time tracker, which is the set model. Now we're going to use the same question, but see how long it takes by using the linear model. Okay, so here we have our linear model, and it shows all of our time, but in a line. So we are going to start just like we did at 2:30. So here's our start. So like we did in our set model, we are going to make 60 again. So in order to make 60 from 2:30 to 3, we are going to have to add 30 minutes to make the hour at 60. So that's 30 minutes. Now, if we look back at our problem, we're still wanting to get to 6:15. So we need to make 60 and jump 1 hour to 4. Then we need to jump another hour to 5. Then we're going to jump another hour to 6, which is another 60 minutes. And again, we're trying to get to 6:15. So that we have 30 minutes, 60, 60, and 60. So for us to get to 6:15, we need to jump 15 minutes. And that is our end. So as we can see here on our linear model, we jumped in order from 2:30 to 6:15. So since Roseanne has to be home by 6:15, we're trying to see how long she has to go prepare dinner. So we needed to do all of those jumps in order to see how many minutes we had. So now we're going to take up all of our numbers, well, our minutes that she had, and we're going to add them up to see how long it takes. So we can do it right here. So we have 30 minutes, 60 minutes, 60 minutes, 60 minutes, and 15 minutes. So again, we have a 5, and then we have 6, 12, 18, 19, 20, 21, and 22. So in total, it took her she had 225 minutes before she had to be back home to prepare dinner. So 225 minutes is how many minutes she had. And with this problem, we use the linear model to see how long Roseanne had to run her errands.